All right, again, this is page 308, 1 through 27. You can kind of omit the word problem for now. All right, but we're going to go ahead and get started. Now, today is going to start out, it is kind of easy, but it does get a little bit more complicated. And again, today is a really good day to see how much you actually understand numbers. All right, we are going to talk about compound inequalities. Compound inequalities when you have the solution to two inequalities, and that you have to account for lots of different situations. All right, so hey, again, everybody go ahead and write down question number 1. All right, write down question number 1. We'll get started. I'd like to get a whole bunch of the work done. I can get a lot of it done. All right. All right, here we go. We'll go with the first two here. All right. Now, again, it's not that much different other than the fact that there are just two inequalities. All right. The problem comes when you try to answer that the two inequalities simultaneously. So let's look at this real quick and see if you understand what I mean. So the first thing we do is we just have to add 8 to both sides for the first one, correct? So you should be able to easily see that 12 is less than or equal to P, but because we write the variable first, we're going to just go ahead and say that P is what? Greater than or equal to 12. Now, here's where it comes into a little bit of problem. The word and, all right? Now, I want to tell you something. If you have an and statement, that means it's true for both statements, all right? So now, let's see if you understand what I mean. On the second part, I have to add 14, so it would be what? P is less than or equal to what? 16. All right? So now, why is this important? Because I want you to tell me the numbers that are greater than or equal to 12 and less than or equal to 16. Now, hopefully, you can just think about that and say, well, that means they are what? Yes. Now, are those the only numbers?
Well, you could do like
Everything what? Yes, that's what I want you to say. Everything in between. But let's look at that. All right? So here is the number line. Here is 12. And here is 16. If I'm interested in the numbers that are greater than or equal to 12, we would look something like this. And if I'd look at the numbers less than or equal to 16, it would be from here to here. All right? So the solution is everything between what? 12 and 16. All right? Now, look right here. So my answer is just 12 and 16. All right? Now, if I ask you about, for example, just to make sure this is, you understand what I'm saying, right here, if I ask you about 17, is 17 greater than 12?
Yes.
Yes. 17 is greater than 12. And is 17 less than 16? No. That's why it's not true. All right, that's why 17 would not be a solution. Although 17 is greater than 12, it is not what? It is not less than 16. Quickly.
Is this the box and whiskers?
No, has nothing to do with box and whiskers. All right? These are called compound inequalities. All right? Now, for the next one. All right, I don't think that was that bad. All right, for the next one now, we have what's referred to as an or statement. And let me say this. An or statement means that it's true for one or the other or both. All right, so an or statement can be true for one of the inequalities or both of the inequalities. All right, now let's see how that figures. All right, so the first one, we're just subtracting 6 from both sides. And so we have R is less than negative 14. Everybody good with that so far? And then for the next one, we have to do what? add 3. So we would say R is greater than negative 7. All right, so now if we just look at this graphically to see what that means, all right, we would see negative 14 is over here. We would say negative 7 is over here. And I would want the numbers less than negative 14. So the numbers less than negative 14 are going in this direction. And the numbers greater than negative 7 are going in this direction. And it's been a while, so I'm going to go ahead and put infinity over here, negative infinity over here, just to make sure you remember that. Now, I'm looking for the numbers that are either less than negative 14 or greater than negative 7. Now, these numbers over here, those would work because those are what? Less than. All right? Would any of these numbers in here work? No, because, for example, negative 12 is not less than negative 14 or greater than negative 7. So none of those will work. All right? Then we come back to these numbers right here. Will those numbers work? Yes, because those are the numbers that are what? Greater than negative 7. And because it is an OR statement, the numbers only have to be true for one of those statements. So our answer in this particular case, we would say, is from negative infinity to negative 14. Then this symbol right here is the union symbol, which just means together. All right? Negative 7 to infinity. All right? Now, please think about that for a second. It is going to get a little bit more complicated. All right? But that is my solution. What? Yes. All right, exactly. All right, any questions? All right, so now let me go ahead and grab 3 and 4, and we can see if I'm making sense here. All right, here we go. So everybody take a look quickly at number 3 for me. All right, now we all should be able to say what? I'm just going to subtract 7 and divide by 4. And if I subtract 7, I get what? And if I divide by 4, I get 6. So I'm hoping you can go, wow, I'm pretty good at the mental math now. So I'd really wish you could just say 4a is greater than or equal to what? Oh, well, actually I wanted to just do what? Yeah. A is greater than or equal to what? 6. Or A is greater than 5. All right, so now this is the time where I really need your attention. If you are paying attention, I think it's pretty easy. All right. I already said an OR statement has to be true for what? One or the other, or what? Or both. So here's what I want to take a look at. I want to draw the number line real quick. I want to put a 5 here, and I want to put a 6. And if I'm greater than or equal to 6, greater than or equal to 6 looks like this. Uh-oh. And greater than 5 would look something like this. So everybody agree with that? All right. Now the hard part. The hard part is actually telling me what the answer is. What numbers are greater than 5 or greater than 6? What do you think? 5 to infinity. That is exactly correct. Very smart. All right, we would say 5 to infinity. Right? So my answer is 5 to infinity. Now let's talk about it just to make sure you understand. These numbers right here, are they greater than 5? Yes. So that's a solution. Would you agree? Yes. Now, are those numbers greater than 6? No. But because it's an OR statement, it has to only be true for what? One of them. All right. Now let's talk about this right here. These numbers, are those numbers greater than 5? Are they greater than 6? Yes. All right. So those satisfy the condition as well. All right. So the answer is all numbers greater than 5. All numbers greater than 5. The The reason, put your hands down, the reason why the answer is all numbers greater than 5 is because those are the numbers that satisfy at least one of the conditions.
Yeah.
All right, hold up a minute. Let me say one more thing. Now, the other thing is this. If I said it was an and statement, now this will help me understand whether or not you are hearing me. If it is an and statement, if I said, what are the numbers greater than or equal to 6 and greater than 5, my answer would be what?
It would be 6 to infinity.
6 to infinity. Everybody agree with me on that? All right, that's the difference between an and or. An and statement has to be true for both conditions. An or statement has to be true for simply one or the other or what? Both. Quickly.
For 5 to infinity, I thought the numbers had to be greater than 5. So I thought you had to write 6 to
What number is greater than, what's the first number greater than 5? Shh.
5.
Exactly, that's why we wouldn't start at 6. Does that make sense? Right? The reason, again, the first number greater than 5, there is no first number greater than 5. Does everybody agree?
Yeah.
We can't say 5.000001. Right? That's why we have an open circle. That just tells the person it's everything up to but not including that. All right? Same principle there. All right? What? Anybody have any other questions with this? All right, you have to hear me. And must be true for both statements. Or one or the other or both. Quick.
So if it's and, it would be 6 because it's greater than 5 and it's greater.
That's exactly right. Because these numbers right here, watch. These numbers in here are greater than 5, but they are not what? That's why they wouldn't work if it was an and. All right? Now, number 4. This is about as easy as it gets now. It looks complicated, but it's really simple. All right? I need to know that I'm trying to still isolate the variable. So to isolate the variable, I'm simply going to subtract 4. But I'm going to write it like this, and then you won't have to anymore. I'm going to write minus 4, just so you can see that I have to subtract 4 from both sides of the inequality. All right? And when I do that, 2 minus 4 is obviously negative 2, less than or equal to g, less than or just less than 3. Now, how do I say that? This is how I want you to say that from now on. G is between negative 2 and 3. That's all that means. G is between negative 2 and 3. So how do I write that? That's how I'm writing it. Any questions? And this, of course, would be a what statement? This is an and statement for those of you guys because you're between what? Negative 2 and what? 3. All right, everybody feeling pretty good about that? All right, now let me grab 5 and 6 real quick, or actually 6 and 7. All right, we're not really doing the word problem for now. All right. Now, 6 and 7 should be pretty easy for you. All right, so take a look at it now. All right, here we go. See if you can do that real quick. Take a look at number 6. The math is easy, all right? And I don't really care if you write the original problem as much as just write the solution. And then you have to interpret the inequality. All right, so for number 6, we can just say that what? F is less than 11, and F is, yes. Now, I would want you to be able to visualize what those numbers are. If you're less than 11 and greater than or equal to 6, that means you're what? In between those two. Do everybody agree? But let's say you're not 100% sure. That's why I like to demonstrate with the number line. It's easy to see, right? If you are greater than or equal to 6, you're going in this direction. If you're less than 11, you're going in this direction. Everybody good with that? Yes, ma'am. Well, because it's not equal to.
Oh, okay.
You with me now, right?
Yeah.
The equal to is the solid. All right, so now we write it in interval notation. We just say from 6 to 11. All right, I feel pretty good about that. Anybody have any other questions?
Why
What?
didn't you do it to this one?
Because I'm between 6 and 11, right? All right, number 7, here we go. Another and statement. Again, see if you're understanding. Go ahead and solve it real quick. All right, so n is what? Less than or equal to -7, and n is greater than or equal to, be careful,
Oh, yeah.
right? So now in your head, you should be thinking about the numbers less than -7 and greater than -12. Are you trying to visualize what those numbers are? And I would hope you would say, well, those are just the numbers between what?
Negative and
Wait a minute now. So if let's look at it and see. So here is -12. Here is -7. If I'm less than or equal to -7, I'm this way. And greater than or equal to -12 is going this way. Everybody see that now? Right, again, I really think that the number line helps you establish that. All right? Well, you could now hopefully see that the answer is just from -12 to -7. Yes, sir.
Would it always be the lowest number to the highest?
No, it's never always.
Why are you writing it -12 to -7?
Which one's smaller? Shh. There you go. You write them in order. You always write from small to large. You always write from small to large. All right. Now let's take a quick look at number 8 now. All right. Let's grab 8 and 9. All right, let's see how you're doing. All right, take a look at number 8, please. And like I said, the arithmetic is very easy. It's just the interpretation that can be a little trouble. So in this case, y is what? Greater than or equal to 8, or y is?
Less than -4.
All right, exactly. All right, so if we're looking at it on a number line, just to make sure, even though eventually you won't need a number line, greater than or equal to 8 is this direction, less than -4 is this direction. And of course, we all know that negative infinity is over here, and infinity is over here. So I would write that as what? Go. That is correct. Yes, ma'am.
So 4 uses infinity and
No, you guys, listen to me. Here's what I'm trying to avoid. I'm always trying to avoid people saying this is how it always is. It's not going to be that in a few minutes. I'm going to change things up on you. And if you're not understanding what and means, and you're not understanding what or means, then as it gets more complicated, you're not going to be able to understand the complicated problems. I want you to just interpret it just the way this is. An or statement has to be true for only one of them. So if I'm looking at the numbers less than -4 and the numbers greater than or equal to 8, those are all a solution because it only has to be true for one of them. Is it possible for me to be less than -4 and greater than 8? That's not possible. All right, it's not possible. So you have to be careful with that. All right, now let's take a look at question number 9. All right, solve that out real quick. Let's go. And then try to write your inequality. Bless you. All right, first and foremost, t is what?
Or greater than or equal to 1.
T is greater than or equal to 1, or?
T is less than 1.
All right, so let's see where we're at. So here we are at -1, here we are at 1. If we're greater than or equal to 1, we're this way. Less than -1 this way. And it's an or statement. All right, because it's an or statement, we can read it as
We can read it as negative infinity to -1, or 1 to infinity.
exactly correct, guys. I don't think that's that hard. And that's why I'm telling you, pay attention. Don't worry about the absolutes. Every problem you should think of differently. And make sure you're answering the question. All right? All right, let me grab 10 and 11. It's getting a little bit harder. All right, so let's see who can do 10 and 11. 10 and 11 should be pretty easy for you. All right, I didn't show you this yet, but it should be pretty intuitive. All right, so everybody try number 10 now. Yes, ma'am.
How do you know if you put like the U in between the two or if it's not one?
Because you have to answer the question.
Yeah, but like on all the other ones, like you only put never mind.
You sure? Right, because I can go back to the previous problems.
I'm confused by those two are like different.
Well, because they have different questions they're asking. One is an and, so it has to be true for both of them. And the other one is an or statement, so it only has to be true for one of them. In a few minutes, going to find out whether or not you really understand what I'm talking about. All right, because they start going in the same direction, they go in opposite directions and say and. There's all kinds of things. All right, that's what I'm saying. You got to be with me right now. All right, so in this case, we're going to do what?
Subtract 7.
And then we're going to,
Divide 3.
yes. All right, so if you subtract 7, we'll be at -12 is less than 3p, which is less than 15. Then you just do what? Divide by 3. So we're at -4. Now, thank you. So here, listen to me real quick. I don't want you to say -4 is less than p, which is less than or equal to 5. I just want you to say p is between -4 and 5. That's how you say that. P is between -4 and 5. All right, so here we go. Everybody happy with that? All right. Now everybody try 11 real quick. 11 should be exactly the same as number 10. Very simple. So first thing we have to do is subtract 4. Then after we subtract 4, we have to divide by 7. All right, so on your paper, please check and make sure you're doing it correctly. If I subtract 4, -7. Then if I subtract 4, I'm at 14. And then I divide by 7. The final answer. Told you. That's pretty easy. That's not hard. It's not hard at all. All right. Now let's see if I can make it a little bit harder now. Here we go. All right, let's start with number 12. Go ahead and write that out and see if you can get it. And these are just two-step equations, so you should be able to just write the answer as far as I'm concerned. So the first one, h is what? Right? And if you're having trouble with that, just speak up. H is greater than or equal to 2. Any issues? And I have h is less than 3. All right, there we go. So now I really want you to be able to look at that and just say, well, that's all the numbers between what? 2 and 3. That's what I'm hoping you can eventually do. It's a little hard as you're starting out. But if you say the number is greater than 2 and less than 3, that just means it's everything what? Between 2 and 3. That's what I want you to be able to tell me. Everything okay? All right, let's check out 13. Let's see. I thought it was getting harder, but maybe not. So let's look at that. Yeah, this is the one where you got to think about it. All right? So after you do the problem and you see why it's a little bit harder, think about it, and then raise your hand and tell me what you think the answer is. But you got to think about it. Who's got it? Who wants to take a shot? What do you think? I want the final answer. 6.
Okay, so it's negative infinity to 6, and then, and with it.
Union.
And then 9 to infinity.
What do you think, Catalina? What did you say? I have no idea. Well, what does it say? All right, never mind. Emily, tell me.
I put 6 and 6 at the numbers between. Well, no, not the number. Just like 4. No, not the 6. 6 and 6.
What do you think?
Negative infinity is to 6 and 8 to infinity.
What do you think?
Negative infinity to 3.
What do you think?
Oh, 6 to infinity.
Negative infinity to 5, and then and then it's 6 to infinity.
What?
Negative infinity to 6, and then the new 6 to infinity.
What do you think?
I put parenthesis negative infinity to 6 bracket u bracket 6 to infinity.
Tell us.
I got no solution.
Good.
Yes.
I said bracket infinity to 6, u, and then I put
Bracket.
Tell us.
You didn't put that you thought it was negative
No, but I
infinity to
figured
6.
it out.
What is the answer? Tell them. Is not an answer.
There is no answer.
I just got like
Yes, no. No solution.
Oh, I got bracket 6 to infinity parentheses.
All right, now we have the answer. Go. Okay. Well, that's the answer then, I'm sure. All right. So let's now see what I think. All right. So if I add 2 and then I divide by 4, I have 6 is greater than. Shh, quiet now. Just listen. Listen. So here we go. If that's true, we want to say that m is less than or equal to 6.
yes.
Or, hey, now's the time where you got to listen. Concentrate. All right, I'm sure everybody got this part right. I'm sure. It's just the answer that's the complicated part. That's why I'm saying just listen. All right, over here, we end up with subtracting 5 and dividing by negative 3. So now we have m is greater than or equal to 6. So if you got that far, you knew You know how to do the arithmetic. You just don't know how to put it all together. All right, so now, here's where you want to listen carefully. This is an or statement. Because it is an or statement, that means it only has to be true for one of them. I want to know all of the numbers that are less than or equal to 6 or that are greater than or equal to 6. That's what? So how do you write everything?
Oh my.
How did you not write that? Negative infinity to infinity. The reason why you couldn't write that because you weren't sure about the or statement. The or statement says that you can go from all numbers are possible.
Is this supposed to be brackets?
No, infinities is never a bracket.
What?
Yeah. It's always in parentheses.
I thought I was going to get Mr. Scrabble.
So again, listen carefully. Hold up. Yes, tell me. I want to talk to you. Okay, infinity is an idea. It's not a number. All right, so infinity is you never get to infinity. All right, a bracket is when you are including that number. You know what I mean? So everybody has to know that now. Infinity never has a bracket. All right, what requires a bracket if there's equal to involved? All right, now again, this is what I'm talking about, is really helping you understand numbers better. But if you're not giving it a shot, you're not going to understand the numbers. There isn't an absolute, this is always the way it's done. All right, you have to think about every single one of them. Sometimes the number line helps, and sometimes the number line is not necessary. So with that, let's check out 14 and 15. All right? Shh. No. It's not. Shh. All right, here we go. Let's check out 14 and 15 and see who's the thinker. All right, 14. Try to get that done. Shh. Give me a second. We're working. All right, so the first one, we would say A is what?
Less than or equal to 7.
What? Don't worry. -4. A is less than or equal to -4. And then if I do the other one,
A is greater than 4.
A is greater than 4. Hey, come on. The work's up here. Don't worry about everything else. All right, concentrate on the math. Charlotte, of course I do.
Negative infinity to -4 and -2 and 4 to infinity.
Tell me. What do you think? You read it to me. What does it say? Come on. Don't tell me you don't have any idea. Wait a minute. Say it again. Nice and loud.
A is less than or equal to -4 and A is greater than 4.
Okay, so now listen to me. It's really this simple. I want you to put your hand down. I want you to tell me a number that's less than -4 and greater than 4. Shh. Tell me a number that's less than -4 and greater than 4. Shh. No. Instead, now, here's what I want you to do to answer this question. Think of a number less than -4.
Oh, wait, no, sorry, no.
It's okay. I know. I know. Negative 5.
Yeah.
Is negative 5 greater than 4?
No.
So that's not an answer. So I'm waiting for another shot.
0?
Well, now
Wait,
remember,
no.
think about it now. Everyone else, no one got it right. One person said something. Okay, so that's what I'm trying to show. You're not the only one. Give me a number less than negative 4. Think of all the numbers that are less than negative 4 in your mind. What would be the, if we're going less than negative 4, what are those numbers?
-6, -7.
Now, which one of those is greater than 4? That's the answer. No solution.
Oh my
gosh.
Jackson!
Now listen, that's what I'm trying to tell you. You if you're not thinking about the numbers, that's what's there are no absolutes. All right? Some of you are asking me questions, well, is it always this way or always this way? That just means you're not interested in thinking about numbers the way you should. I asked you a simple question. Give me a number less than negative 4 that's also greater than 4. Doesn't make any sense. You can't do that. You can't give me a number less than negative 4 and also greater than 4. Put your hand down. It's that simple. It's no solution. Every time they could be tricking you. You have to think about the numbers. What are they asking me? All right, now do the next one. 15. No solution. Easy. Everybody try 15. And I expect you to be able to do a better job on question 15. Again, solving it at first, put your hands down. Solving it first is not going to be hard. Interpreting the answer is what is difficult. Finding the solution is easy. All right, interpreting the inequality, the solution to that compound inequality is tricky. But say it to yourself, each answer. Then you should be fine. So the first response should be what? Y is less than or equal to negative 4. Or Y is doesn't matter. Come on. I'm not correcting anybody. I'm just asking. All right? I don't care if you miss it 100 times. All right? Look up here. If that's not what you got, tell me, and we can make a correction. I didn't say that was the answer. I said those are the solutions to the compound inequality. Now, we need someone to tell me the solution. What? Ava, what? Tell me why it's no solution. Come on, Ava. Come on, that's what I'm trying to get you to see. See, listen, it's not difficult. It's difficult if you never think about it. See, the problem is everybody just wants, here's what the answer is. And I can make it so it's really complicated. Nothing is that complicated if you can just understand what you're saying. So read me the first one. What does this say? Y is less than or equal to negative 4. Perfect. So what are the numbers less than or equal to negative 4? Shh, put your hands down. Stop interrupting me. Then, what else? And? So I'm trying to get you to visualize the numbers are going less than. Then over here, what are those numbers? They're going down also, less than, to the left, right? So what numbers are less than negative 3, put your hand down, less than negative 3 or less than negative 4? Hold on. Now, to help here, again, I always tell kids, if you're struggling at first, the number line is very helpful. So I would put on my paper, here's -3 and here's -4. And here's what I want you to think about. If I am less than -3, I'm going in this direction. Now again, I think this is the easiest way to always get the right answer. But I want you to be able to tell me the answer is without doing the number line. But if you're, hold on, if you're having trouble, that's okay. Now, what numbers are less than -3 or less than -4? I'm listening now. Tell me. That definitely is it. But you would say anything less than what? Shh. Anything less than -4. How about anything less than? Anything less than -3. Because it's an or statement. These numbers work or these numbers work. So the answer was -infinity to -3. Now, those of you guys, listen now. The final thing I need you to do is the homework. All I want you to try is 18 through 27. I want you to review, or I want you to try 18 through 20. Hey, you're not listening. 18 through 27. But I also want you to review, if you thought some of those were tricky, to review those notes on the problems that we just worked on that were trickier. Does everybody understand what I'm saying?
Yes.
All right. Have a good day. That was a great job today. Great.
Thank you, Mr. Brown.
Very, very good.